Okay, let's look at the homework 4.3, 4.4, problem number 10. Right. So we have this function given, 6e to the x squared minus 7x plus 9. And first we need to take the derivative and find the equation of the tangent line at x equals 0. Then we need to find the x value where tangent line is horizontal. Right. So let's do that. Right, so we need to find the derivative, so let's take the derivative. So f prime of x is equal to, right, 6 is just a constant multiple, so I'll just put that there, right. Then derivative of the exponential function, and here, this is the inside function. So inside function is x squared minus 7x plus 9, right. So we just take the derivative of the outside function, but the derivative of e to the x is going to be e to the x. So we're going to just write down exactly the same thing, right? Keep the inside function as it is. So we have x squared minus 7x plus 9, right? Then we have to do a chain rule, multiply by derivative of the inside function, which is going to be 2x, right? Derivative of negative 7x is minus 7, and derivative of 9 is 0, since 9 is a constant, right? So this is the derivative. So let's type it in. All right, so derivative was 6, right? And e to the x squared minus 7x plus 9, and times quantity 2x minus 7, right? So let's check the answer. Right, so we got that. Right, so let's find the equation of the tangent line. Alright, so remember that we always look for two pieces of information whenever you're looking for equation of a line. First one is a point. Right, so let's call it x1 comma y1. Right, this is equal to, right, so x value is given right here, so x is 0. Right, then corresponding y value, you can just plug in x value into the original function. So you have f of 0, right, which is going to be 0 comma, right. So if you plug in 0 here, that's 0 minus 0 plus 9. So you have a 6 e to the 9th power. So 6 e to the 9th power is the y1 value, right? And the second piece of information we need is the slope, right? So slope m is going to be equal to, right? We can look at the derivative, because derivative tells us about the slope of the tangent line. So we look at the derivative and then plug in the x1 value. So in this case, 0. Right? So let's do that. So if you plug in, let's say 0 here, so 6 e to the 9th power, and then you put 0, so it stays negative 7. Right? So it's a negative 7. Maybe I should write that. So it's a 6 e to the 9 multiplied by times negative 7, right? So this is going to be negative 7 times 6 is 42 e to the 9th power, right? So once you have those two pieces of information, we can just use the remember the point slope form. Y minus y1 is equal to m times slope times quantity x minus x1, right? So we just need to plug those numbers in, right? So y minus y1. y1 is 6e to the 9th power, so put that in, 6e to the 9th power, right? Then slope we just have found to be negative 42 e to the 9th power, right? And the quantity x minus, right, x1 is 0, so it's 0 here, right? So let's see, so if you multiply out and try to simplify, right? So I'm gonna add 6e to the 9 to both sides. That way you have y is isolated on the left hand side, and this is just multiply out. So you have negative 42 e to the 9th power x, and the plus 6 e to the 9th power. All right, so so this is the equation of the tangent line. So let's type it in. All right, so the tangent line was negative 42 e to the 9th power x plus 6 e to the 9th power. All right, so let's check the answer. All right, so we got that. All right, so we want to find the x value at which the tangent line is horizontal. All right, so let's do that. All right, so we need to pay attention. So horizontal, if the tangent line is horizontal, this tells you that slope must be 0, right? But if the slope is 0, the derivative there must be 0 as well, because derivative tells you about the slope of the tangent line, right? So we can use that to find the x value, right? So f prime is right here. So all you really need to do is set this guy equal to 0, right? Then notice that all right, 6 is going to be positive, so this guy is never 0, and the exponential function right here, this part is always positive, so it's never 0, right? Then only way we can make it equal to 0 is this guy equal to 0. This is the only chance for this whole thing to be equal to 0, right? So this equation boils down to simply 2x minus 7 equal to 0. All right, then we can solve this. We can just add 7 to both sides. You get 2x is equal to 7, right? Then we can just divide through by 2 to get x equals 7 halves, right? So that's the x value. So let's type it in. All right, so let's see, tangent line horizontal at x equals 7 halves. All right, so let's check the answer. All right, we got that. All right, that's it. I hope that this was clear.